All right, the concentration of an antibiotic in the blood t hours after it has been taken is represented by the function C of t is equal to 4t over 3t squared plus 4. Determine C prime of 3 and interpret its meaning for the situation. Okay, so basically what's happening here is that, you have this antibiotic in the bloodstream. Over time it's deteriorating. We want to figure out what C prime of t is. So first we need to find the instantaneous rate of change, which is the derivative. So C prime of t is basically d of c over dt, right? So I'm going to be utilizing the quotient rule again. So I'm going to do the derivative with respect to change in time of the numerator. So 4t times the denominator, 3t squared plus 4, minus the derivative of the denominator, d over dt, of 3t squared plus 4, times the numerator, which is 4t, okay? And then I'm going to divide all of this by 3t squared plus 4 squared, okay? So that's the denominator squared. Now if I clean this guy up, dc over dt, what I'm going to get here is 4 times 3t squared plus 4 minus the derivative of 3t squared plus 4, which is 6t, times 4t, and in this case you put this over the denominator. So I'm just going to clean up the numerator first and then loop it over the denominator. So I'm just going to look at the numerator independently right now. If I simplify this by expanding it out, I get 12t squared plus 16 minus 24t squared, and then I'm going to get negative 12t squared plus 16. So you can write this as dc over dt is equal to negative 12t squared plus 16 over 3t squared plus 4 squared. Okay, so this is your rate of change function. You want to figure out C prime of 3. So what I'm going to do here is I'm going to let t here equal 3. If I let t equal 3, you get negative 12 times 3 squared plus 16 over 3 times 3 squared plus 4 squared, and that gives me negative 12 times 9 plus 16, okay, so there's a 9 here, plus 16 over 3 squared is 9 times 3 is 27 plus 4 squared, and this gives me negative 108 plus 16 over, what is that, 31 squared. Okay, and let me crunch this out and see what we get. So dc over dt when t is equal to 3 is negative 0.0957. Okay, so this tells us that we have a negative slope, right? So this is basically the loss of concentration. This is the loss of concentration at t is equal to 3 seconds, right? So at t is equal to 3 seconds, we're basically losing a concentration of 0.957 of the antibiotic.